Hello guys, welcome back into the mathematical lesson. We are still continuing with answering these riders, the Euclidean geometry, the circle Euclidean geometry. So in front of the screen here, I'm having the question 9.2 here. It says to us in the figure below, we are given the angle DCO as 25 degrees and O as the center of this circle. The points A, B, E, C, A, B, E, C, and D are points on the circumference of the circle. Okay. Now calculate given the reasons, the size of. Then the questions is angle D1, angle O1, angle A1, and angle E. So okay, we are given this angle here as 25 degrees, DCO, this angle here. So we'll go for our beautiful technique, as usual, DRCPT, Dr. Cape Town technique. Okay, DRCPT. So D. You will ask yourself if there is any diameter in the diagram. So we look at the diagram, okay, we find that we were given that, oh, it is the center of this circle. Therefore, if there is this line that moves from the circumference to the circumference and it passes through the center, that line is the diameter. But now, there is no that angle that is subtended by this diameter in any of this diagram. Therefore, we can't use that theorem that says angle subtended by the diameter or angle in a semicircle. Now, we can just cancel that letter. We are done with it. We go for R, the radius. OD is the line from the center to any point on circumference, meaning OD is the radius. OC is also the radius as it moves from O, which is the center, to any point on circumference C. And OB is also a radius. It moves from the center to the circumference. Therefore, now the triangle DOC is an isosceles triangle. Why? Because OD is equal to OC. They are both radii. Now it forces angle D1 to also be equal to that 25 there. Reason being, angles opposite equal sides or the base of an isosceles triangle. We are done with the radius. We can go for that theorem that says a radius perpendicular to the tangent. Why? Because there is no tangent that is existing in this diagram or that we are given. Now we are done with that R of ours here. We'll go to C, the cyclic quad, and we find that ABEC is a cyclic quad as its vertices touches the circumference. Now we know the properties of a cyclic quad states that opposite angles of this cyclic quad are supplementary. What do we mean by supplementary? It simply means that this angle plus this angle is equal to 180 degrees, and angle B and angle C are also supplementary. We also have this cyclic quad here, DBEC, this one. So this angle and that angle are supplementary, and this angle and that one are supplementary. Why? Because they are opposite angles of this cyclic quad. Now we are done with that C. We'll go for P, parallel lines, but unfortunately there are no any parallel lines in this diagram. T, there is no tangent. Now, we can simply dive into the problems and see what we can do to answer the questions that we are required to answer. Now, in 9.2.1, we are required to find the size of angle D1. Of course, we already found the size of angle D1. We said it is equals to 25 degrees, not just 25. But now, what is the reason behind this statement? Why do we say angle D1 is equal to 25 degrees? It is because OD is equal to OC, that is radii. Now, since we have the radii equals to each other, now why do we say this is equal to that? Because they are both angles opposite equal sides. They are angle opposite equal sides. Now we will go for the next question that says to us, we need to calculate the size of angle O1. Angle O1 is that one that we can see it is on the center of this circumference of this circle. Now we have that angle at the circumference. By theorem 2, that angle at the center is exactly 2 times angle at the circumference. Now angle O1 will be equals to 50 degrees. Why? Because angle at the center is 2 times angle at the circumference. Yes. The next question, 9.2.3, requires us to find the size of angle A1. Now, we can see or identify this bow tie shape here. Now, this angle is equal to that angle, and this angle is equal to that angle. Reason being, angles subtended by same chord or same arc or angles in the same segment. Now, angle A1 is equal to angle D1. Okay, angle A1 is equal to angle D1. They are both equals to 25 degrees. Why? Angles in the same seg. In the same segment, or angles subtended by the same arc of chord. Okay, the next question, 9.2.4, requires us to find the size of angle E. And angle E is opposite angle D1. Therefore, those two angles are supplementary. Then now for this one, we will simply say 180 degrees minus 25, not 125, but minus 25 degrees. That is equal to 155. And 155 degrees, not just 155. Reason behind the statement states that opposite angles of a cyclic quad are supplementary. Now you have your beautiful 14 marks inside the pocket. I hope this makes sense. Now we can proceed to the next question. This one is the same as this one that we just did. I will jump this one. I will jump straight to this question 10. We will start by reading the statements that we are given. They say to us, points A, B, C, and D are the points on the circumference of the circle in the diagram below. ECF is a tangent at C. This ECF touches the circle at C. Now, angle B1 is equal to angle B2. These angles are equal. We need to mark that this angle is equal to this angle. Okay, now we'll go for our technique, DRCPT. D, diameter, there is no diameter. R, there is no radius. Why? Because this circle doesn't even have a center, so can't say this is a radius, while we don't even know if this is a center of the circle. Now we'll go for C, cyclic quad. We don't have that cyclic quad that is like this, but we have that bow tie shape here. We can identify it here. It is A, B, D, C. Therefore, we can go for angles in the same segment. Angle A is equal to angle D, reason being angles in the same segment, or angle subtended by the same arc, which is this one, or subtended by the chord that can be thrown here, AD. And also angle B1 here is equal to angle C2, reason being angles in the same segment. or angle subtended by the same chord, which is BC, or the same arc BC. Now we are done with the cyclic chord part. P, parallel lines, there are no any parallel lines. T, the tangent, we can go for the tan chord theorem. Tan chord theorem states that now the angle between the tangent and the chord, which is C1, between the tangent and the chord, in this triangle, that angle will be equal to the angle that is opposite that chord. Now angle B2 will be equal to angle C1. And also in this side, angle C4 is equal to angle D, reason being tan chord theorem. We come to this angle C1 plus C2 between the tangent and the chord is equal to, in the triangle, the angle that is opposite that chord. Therefore, it is equal to this angle, reason being a tan chord theorem. Also, this angle here between the tangent and the chord in this triangle will be equal to the angle that is exactly opposite that chord of ours, which is this one here, right? Okay, now we are done using that tangent part. We can jump into the problems and see how it goes with those problems. Let me erase this mess that I made here. Now, 10.1 says to us, if angle B1 is equal to X. Now, we'll go to B1 there and label it as X because we were given that B1 is equal to B2. Now, we will write X here. That is given on the statement. Find with reasons two other angles that are equal to X if B1 is equal to X. So the first one, you will say angle B2 is equal to X as well, is equals to B1. Why do we say this? We were given it there on the statement. The reason is given, right? Then the second one, we said this is a bow tie, this one, and we said this angle is equal to that angle, reason being angles in the same segment or angles subtended by the same chord or angle subtended by the same arc. Now I will say angle C2, and I write that head to show that I'm talking about an angle here. So angle C2 is equal to angle B1. Yeah, all equals to X. What is the reason behind that? Angles are in the same segment. Fine. Or angles subtended by the same arc. You can say this arc or this chord. Any of the two is correct. Then now you get your mark for the statement, your mark for the reason, your mark for the statement, your mark for the reasoning. Now you have your beautiful 4 marks in your pocket. We go to the next question at 10.2. 10.2 is says to us, hence, you can use this hence means you can use the previous information that you used in the previous question. Now, hence, show that DC bisects ACF. Where is DC? This is DC, right? Bisects ACF, an angle ACF, right? We need to show that this angle is being divided by this line into two equal parts. That is the definition of a bisect. So you guys need to be sure that you know how to differentiate between two terms, bisect and intersect. Intersect, we said bisect, it means it cuts something into two equal parts. and then bisect, they just cut each other in any terms. They just cross each other at any terms, or they just touch each other. For instance, we can say AC and BC intersect at a point M, given that this point is M. That is just intersecting. Okay, I hope that makes sense. So now we have shown in 10.1 that this angle is X. We said the reason behind that statement is because those are the angles in the same segment. So now we have to show that this angle is also X. We said this is an angle between the tangent and the chord. We said this is the angle between the tangent and the chord. Therefore, if we go to this triangle BCD, we will go to the angle that is exactly opposite to that chord, which is this one. So this angle will be equal to that angle. Now, we also have X here. Now, you will say, for this answer here, you will just simply take this part, you put it there. The second part is that C1, an angle, is equal to angle B2. They're both equal to X. Why? Because of turn-chord theorem. Turn-chord theorem. Fine. Now, we will say, therefore, DC bisects angle ACF, since C2 is equal to C1, and the angles with those heads on top of the letters, just to be sure that you have shown that these letters that we are talking about represents the angles. Okay, let's go to the next question, guys. Question 11. 11.1 requires us to complete this statement. They say, opposite angles of a cyclic quad. Oh, we've been talking about this theorem a lot. Now, opposite angles of a cyclic quad are supplementary. Or you can say opposite angles of a cyclic quad adds up to 180 degrees. Any of the two is 100% correct. Now, let us go to the next question, 11.2. They say to us, in the figure below, ABCD is a cyclic quad. ABCD is a cyclic quad. We are also given that AB is parallel to DC. AB is parallel to DC, okay? This is parallel to that. In the circle with the center O, okay. BC and AD produced to meet M, okay? BC and AD are being produced and they both meet at M. Okay, now D3 as angle is given to us as X. Yeah, okay, lovely. Now, show that MC is equal to MD. Show that MC is equal to MD. How are we going to show that? But before we can dive into the problems, let us quickly do our analysis using the technique DRCET, the Dr. Cape Town technique. D, the diameter, but there is no any diameter here. We go for R, the radius. This is the radius. Okay, okay, they are equal, but there's no line here that joins B and D in order to form an isosceles triangle here. So we can just skip R because there's also no that theorem that says a radius is perpendicular to the tangent. Now, let's go to C, the cyclic quad. We are given that ABCD is a cyclic quad. Therefore, this angle and this angle are supplementary. This angle whole B and D1 plus D2 are also supplementary. And then remember we are having that theorem that is like this. If this is a cyclic quad, this angle is equal to that angle. Reason being, exterior angle of a cyclic quad is equal to interior opposite angle. Therefore, we are having this angle here. This one is equal to that one. Reason being, exterior angle of a cyclic quad is equal to the interior opposite angle. Also, this one is equal to that one. Exterior angle of a cyclic quad is equal to the interior opposite angle. We go for P, parallel lines. Now, we were given that AB is parallel to DC. Therefore, if this line is parallel to this one, this angle will be equal to this angle. They form my beautiful F there, reason being corresponding angles, because AB is parallel to DC. Also on this side, angle A is equal to angle D3, reason being corresponding angles because AB is parallel to DC. Now, we also have angle A and this angle co-interior angles. This one and this one co-interior angles, but I don't think we have alternating angles here, but we will see maybe when we have to answer some questions. Now, question 11.2.1 requires me to show that MC, this line, is equal to MD. Now, that is the property of an isosceles triangle. Now, what do we have to do with that? We have to show that this angle is equal to that angle. Now, how are we going to do that? How are we going to show that this angle is equal to x? Because we were given that this angle D3 here is equal to x. So this angle will be equals to that angle is x, that whole angle. Oh, beautiful. From there, we take it here. So the first thing that you will do, you will say that D3 is equal to angle ABC. That angle ABC at B, they are both equal to x, y, exterior angle of a cyclic quad. Exterior angle of a cyclic quad is equal to the interior opposite angle of this cyclic quad. Now, this angle is equal to this angle. Angle ABC there at B is equal to angle C2. They're both equal to x. Why? We said corresponding angles, right? Corresponding angles are equal. Why? Because AB is parallel to DC. Yes. Now you are done because now we'll just simply say since angle C2 is equal to angle D3. You can simply say line MC is equal to the line MD. Why? Now we have sides equal, opposite equal angles. Sides opposite equal angles. You are done with 11.2.1. Now let us go to the next question, which is 11.2.2, which states that if D3 is equal, is it this 3? Let me just confirm this here if it's D3 or D1. I'm not sure if I see it correctly. Let me quickly check it here. Okay. I'm avoiding that thing of maybe assuming that it says D3 and then now we end up doing the wrong calculations. We end up maybe not finding the answer of what we have to get because we assumed the wrong thing. Where is this question? on the question papers. Please bear with me, guys. Oh, there we go. Yeah, it says if D3 is equal to X. If D3 is equal to X, determine the value of M in terms of X. Where is M? This is M. We have that X, we have X here. So now remember M will just be equals to 180 degrees minus X, which is just minus 2X. Reason being the interior angles of a triangle, right? Yes. Let us go to the next one, which is the last one, 11.2.3. Hence, show that BODM is a cyclic quad. BODM. BODM is a cyclic quad. Maybe if you draw a circle here, it satisfies the properties of a cyclic quad. Now, you will say, what is O1? Because O1 and M, we can see there that they are opposite angles if this is a cyclic quad. Now, what is O1? Okay, O1 is angle at the center. This is angle at the circumference. Therefore, this will be 2x. Why is this x? Because these lines are parallel to each other. Therefore, they form my beautiful F there. Reason will be corresponding angles since this is parallel to that. Now, what is this angle? Now we will say angle M plus angle O1 is equal to, what is M? It is 180 degrees minus 2x. What is O1? It is 2x. Now they cancel each other. Now we have shown that these angles are supplementary, right? Therefore, you will say BODM is a cyclic quadrilateral. Now you are done with everything that you were required to do. Otherwise, let us end here for this lesson, guys. We will meet in the next lesson. I hope you enjoyed these lessons and everything.